This is notes section 12.3 and 12.5, area and volume for pyramids and cones. So first let's talk about what a pyramid is. A pyramid is a solid formed by a polygonal base. With triangular faces. That meet at a common vertex. So in these two pictures, this would be a square pyramid. This would be your base. And in our square pyramid, or any pyramid, you will always have a height to look for. So this is an important part to find the area and volume. So this would be your height. And it always meets at a right angle. And then we have something that's called the slant height. So the slant height starts at the vertex and travels down the side of one of the pyramids. Okay. So this would be called your slant height. And let's make this a little bit better of a triangle. Here we go. Okay, so slant height is from one of the sides, and if I were to draw it on the net of a square pyramid, it would be this length right here. Okay, and again, with your square pyramid, the net, this would be your base. So we also can call the height of our pyramid the altitude. Okay. All right. Slant height is the height of a lateral face. So lateral, if you guys remember, means sides. So all the sides of the pyramid will be the lateral sides. So all the triangles. So that's the height of our slant height. Okay. If we have a cone, the height of the cone is 90 degrees from the center, so this would be the height. And then your slant height would be the slant height of the cone, so it would be this part right here. Okay. Alright, so let's take a look at a cone. So cone is a solid with a circular base. And a vertex not in the same plane. So here, this would be the vertex that we're talking about. Okay. Again, here would be your height. This would be the slant height. All right, and just so you know what the net of a cone looks like, here would be the net of your cone, and this would be the base. Okay, so this, because this height creates a right angle, this is a right cone. And because this cone is slanted, this makes it an oblique cone. Okay, so in an oblique cone, you just have to find the height by finding where your right angle would be to create the height. Okay, so just like we did in 12.2 and 12.4, we're going to use formulas. These are ones you need to memorize. All right, and these are all for regular pyramids and cones. So that means the regular would be the bases. The base of the pyramid is a regular shape, so square, triangle, all would have congruent sides and angles. Okay, so lateral area, you can abbreviate L or LA, will be 1/2 times the perimeter or circumference if we're talking about a cone, times the slant height. Okay. The surface area, you can say S or SA, is equal to the lateral area plus the area of the base. So if in other words, we can say 1/2 the perimeter times the slant height plus the area of the base. Now, volume of a pyramid or a cone is special because really it's 1/3 of the whole solid prism. So we say the volume is 1/3 the area of the base times the height. Okay, so these are ones you need to have memorized. So in each section, we're going to find the perimeter of the base, the slant height of our solid, and the area of the base, and the height from the vertex to base of our solid. So what that means is if we take a look at this height from here, this was our vertex, and this is to the base. So vertex to base, that's the height we want to use in these formulas. Okay. All right, so let's try some examples. The first one, it says, find the surface area of a square pyramid with base edge 15 centimeters and a slant height of 9 centimeters. Okay, so let's label our picture. We have the base edge is 15 centimeters, and it's a square pyramid, so this is also 15. Okay. All right, and I'm going to draw in a dotted line for the height, and then drawing the slant height here, because it gives me the slant height as 9 centimeters. And we're actually going to have to find the height of our square pyramid. I'm sorry, we're not going to have to find, we just need the slant height. So that's the nice thing about the surface area. If you look at our equation, the lateral area plus the base, well, our lateral area, you guys, only has to do with the slant height. So that's really nice. If it asked for volume, which we will do an example later, then yes, we would have to find the height. Okay. All right. So we need to find the perimeter. So the perimeter of the base would be, since there's 4 sides, 4 times 15. which is 60 centimeters. All right, and we need to find the slant height for our equation, which is given to us as 9 centimeters. And then the area of the base, which would be 15 times 15, or 15 squared, which we know is 225 centimeters squared. Okay. So for our surface area equation, which is 1/2 the perimeter times the slant height plus the area of the base, now we have everything we need to plug into the formula. Okay. All right, so surface area is equal to 1/2. Our perimeter is 60. Our slant height is 9, and the area of the base is 225 centimeters squared. Okay. All right, so we end up getting 270 plus 225, and my surface area is 495 centimeters squared. Okay. All right, this time we're given the height and we have to find the slant height. So again, I'm going to draw in what I know. I'm drawing the height, which we know is 97 inches. And we have to find the slant height. So I'm going to just label that L. And the base edge is 90 inches. So 90 by 90. Okay. All right, so how do we solve this? Well, notice this is a right triangle, and because we have a square base, if you remember looking at the apothem is also half of our sides, only for a square. So this part, and when I talk about the apothem, I'm just talking about the apothem from the base view. This part is half a 90. So if I draw in this triangle, we know the height's 97. We are trying to find the slant height, and we know this is 45. So what do? We use the Pythagorean theorem. Okay. So first, let's write down, we know our perimeter is 4 times 90, which is 360 inches. The slant height we can solve by taking the Pythagorean theorem, so 45 squared plus 97 squared equals the slant height squared. The square root of that, let's go out 2 decimal places, so square root of 45 squared plus 97 squared is approximately 106.93 inches. All right, and then the other thing, because it's asking for the surface area, so we need the base, area of the base, which is 90 times 90, so 8,100 inches squared. All right, surface area. We know our equation from up here, so 1/2. The perimeter is 360 times the slant height in 106.93 plus 8,100. And I end up with 27,349.4 inches squared is my final answer. Woo, okay. So we have a couple more examples on the back, dealing with a cone, a hexagonal pyramid, and an oblique cone, okay, which you will need for the homework. So let's take a look at number 3, keyword here, exact. Okay, so that means either in terms of pi or simplest square root. So since I have a cone, I know I'm going to have to have pi in my answer since it's asking for the exact surface area and volume. Okay, so we need to find all 4 options. So we need to find the perimeter, which in this case would be the circumference, because we have a circular base. So we have a diameter of 10 meters, which means the radius will be 5 meters. The height is 12 meters. So circumference would be 2 pi r. Well, our radius is 5. 5 times 2 is 10, so we get 10 pi meters. Slant height, so on a cone, remember this guy is the slant height, so we're going to have to use Pythagorean theorem to find the slant height. Well, if you notice here, this is a Pythagorean triple, so this would be 5, 12, and your slant height is 13. Or if you're not sure it's a Pythagorean triple or don't recognize it, then you can always use the Pythagorean theorem. So 13 meters. Okay. Area of the base, because again, we have a circle as the base, so it's going to be pi r squared. So pi 5 squared, which would be 25 pi meters squared. And last but not least, we have to use the height because we're also searching for the volume. So the height that's given to us is 12 meters. Okay, so let's start off with finding the surface area, which we know is 1/2 the perimeter times the slant height plus the base. Now you guys, to help you memorize these, I would write them every problem where you have a surface area so you can memorize the formula. Okay, so 1/2 the perimeter, or our circumference, is 10 pi times the slant height, which is 13, plus the area of the base, which is 25 pi. Alright, so if I clean this up a little bit, half of 10 is 5. 5 times 13, we get 65 pi plus 25 pi is 90 pi meters squared. Alright, so that's our surface area. The volume, let's do the volume over here. Volume, remember, is 1/3 the area of the base times the height. So 1/3 area of our base is 25 pi, and the height is 13. Oops, sorry, not 13, 12. 13 is the slant height, 12 is the height. Okay, all right, when I multiply this out, I get 83 1/3 because we want exact, so leave our fraction. pi meters cubed. Don't forget, you guys, volume is cubic units, meters, or in this case it'd be meters cubed, and surface area would be just squared. Okay. All right, let's try this next one, the exact volume of a hexagonal pyramid. We will need the perimeter. Since we're looking at the volume, we don't need the slant height, but we need the height of the pyramid, and we need the area of the base. Okay, so it tells us each base edge is 4 feet, and the height is 10. So if we have 6 sides, we can easily find the perimeter. So 4 times 6, 24 feet. The height is given to us as 10. Now the area of the base is where it gets tricky. So the base is a hexagon, and since each side is 4, it's a regular hexagon. So we have to use our 1/2 the apothem times perimeter to find the area of this base. Okay. The nice thing is that it's a hexagon, so if I take 360 divided by 6, I know that this angle is 60 and half is 60 is 30. So we're working with a 30, 60, 90 special right triangle. So this is 30, this is 60, and this apothem splits this into 2, so this is 2 feet by 2 feet. So our apothem would be 2 square roots of 3, since it's across the 60, and our radius would be 4. Okay. Well, the nice thing is we already have the perimeter from up above, and we have 1/2 times 2 root 3 times 24. So we have 1/2 times 2 is 1, 1 times 24 is 24. So the area is 24 square roots of 3 feet squared. Now the volume is what we're looking for, which is 1/3 area of the base times the height. So 1/3 times 24 square roots of 3 times our height, which is 10, gives us 240 square roots of 3 over 3, which is 80 square roots of 3 feet cubed. Okay, don't forget to double check your units. Volume, cubed, surface area, or anything to do with area would be squared. Okay, last but not least, find the exact volume of the oblique cone. So notice here that they draw the height of the oblique cone in for you, and to give away what the height is, it has to be perpendicular. Okay, so this right angle tells me that the height is 12, and I need to find the perimeter and the area of the base. Okay, since we have a cone, our perimeter is really the circumference. Okay, and our circumference here would be 2 pi times 6, which is 12 pi centimeters. Area of the base is pi r squared. So pi times 6 squared gives me 36 pi. So the volume, which we need to know is 1/3 area of the base times height, really is 1/3 times 36 pi times the height, which really we didn't need to know the perimeter, but we did need to know what the height and the base were to find the volume. All right, so 1/3 times 36 times 12 gives us 144 pi centimeters cubed. Right, and again, keyword is exact, so your answer must be in terms of pi.